Namaste. Welcome to First PUC Computer Science video classes, Chapter 1 Computer System. Main component of a computer is microprocessors. A microprocessor is a processor which is implemented on a single microchip. It is a small sized electronic component that carries out various tasks involved in data processing, including arithmetic and logical operations. That means the CPU synonymously used with the microprocessor. What does the microprocessor has? The microprocessor has the CPU inside it. It is the main component of a computer system. What are the features of microprocessors? The processing capability of any microprocessor, that is nothing but the computational speed of a microprocessor depends on the kind of microprocessor used in your computer system. The microprocessor is capable of processing millions of instructions per milliseconds. The speed of microprocessor is clock speed, and it is measured in terms of kilohertz, megahertz, and gigahertz. Since microprocessor is an important component of every computer, the speed of processing depends on the processing speed of a CPU, and the CPU is synonymally used as the microprocessor. Therefore, it makes a sense and important to study the different generations of microprocessor. There are 5 generations of microprocessor. In the first generation, it started between 1971 and 73. Word size was limited to 4 bits or 8 bits. The maximum memory capacity of the primary memory is just 1 kilobyte. The processing speed is just 108 kilohertz to 200 kilohertz. The number of cores in the first generation microprocessor is a single core, and example of first generation microprocessor is Intel's 8080. 8080 is the name of the processor. The second generation microprocessor started in the year 1974 and 78. LSI kind of microprocessor was used. The word size was 8-bit, and the maximum memory size was 1 megabyte. The clock speed of the microprocessor was just 2 megahertz, up to 2 megahertz, and it is also a single core and a very popular example of second generation microprocessors are Motorola 6800 and Intel 8085 processors. The third generation started in the year 1979 and 80. VLSI chip type was used. The word size was 16-bit. Memory size was 16 MB. 4 megahertz to 6 megahertz was the processor speed, and it is also a single core. Very popular third generation microprocessor is Intel 8086. In the fourth generation started in the year 1981 and 95. VLSI type of microchips were used. The word size was 32-bit. 4 GB was the maximum memory size, and the speed increased to 133 megahertz. It was a single core microprocessor, 80386 microprocessor, and Motorola 68030 are the example of 4th generation microprocessors. In the 5th generation, started in the 1995, and till the date we are in the 5th generation microprocessor. SLSI kind of microprocessor chip was used, and the word size capacity is 64-bit. and the maximum memory size is 64 GB. Clock speed is increased to 34 gigahertz, and it is a multi-core microprocessor. Example is Pentium 1, Pentium 2, Pentium 3, Pentium 4, i3, i5, i7, etc. What are the specification of a microprocessor? Microprocessors are classified on the basis of different features that includes chip type, word size, memory size, and the clock speed of the microprocessor. Let us understand each one in detail. What is a word size in a microprocessor? How does it matter? A word size is the maximum number of bits that a microprocessor can process at a time. This is the definition of a word size. Let us understand by this way. Suppose there are 100 bits stored in the primary memory, but the CPU word size is 8 bits. That means from the memory it can carry 8 bits in one time, because CPU can process only 8 bits at a time. And how many times does the 100 bits require to be sent to the CPU for process? Approximately 12 times. So, though the CPU is capable of doing faster calculation, non-availability of sufficient bits, it can process limitedly. More time is used to carry all the 100 bits from one end to another end. How many times? 12 times. If the CPU word sizing is increased to 32 bits, how does it matter and improve the processing speed? Let us understand. With the same 100 bits, I want to transfer from this end to this end, from memory to CPU. What is the word size? 32 bits is the word size of your CPU. That means in one time it can carry 32 bits from here to the CPU. It can process 32 bits in one time. So to carry 100 bits to the CPU, how many times is required to carry? 3 times is sufficient to carry all the 100 bits to the CPU because of the 32 bits. Here 12 times it takes, whereas here it takes 3 times. 3 times only. That means CPU is getting more data in 32 bits than in 8 bits for process. So the word size is very important to enhance the speed of the microprocessor. The word size is the maximum number of bits that a microprocessor can process at a time, in one time. What are the different word sizes? The different word sizes are 4 bits, 8 bits, 16 bits, 32 bits, and 64 bits. Remember, the first generation, what was the word size? Just a 4 bits, right? So, what are the different word sizes? The different word sizes are 4 bits, 8 bits, 16 bits, 32 bits, and 64 bits. Now, what is the memory size? Word size is different, memory size is different. The memory size is nothing but what is the total amount of data that can be stored in the memory. That is memory size. How much of data can be sent from memory to the CPU? That depends on the word size of the CPU. Okay. So, depending upon the word size, the size of RAM also varies. There is an interconnection between the word size and the memory size. Initially, the RAM size was very small. It was just a 4 MB due to 4 bits or 8 bits word size. So the 4 bits word size can generate up to 4 MB of memory addresses at the most. Therefore, it was limited to just 4 MB. So the data will be stored in different locations. Okay, those addresses should be carried from microcontroller to the CPU or to the primary memory. What is the length of that memory address? Depends on the word size. Therefore, word size and the memory size are matched. A word size increased to 64 bits nowadays in the latest computers. We have 64-bit word size capacity in the i3, i5 and i7 microprocessors. It can access the RAM to the size of up to 16 exabytes. EB stands for exabytes. So my RAM size can be up to 16 exabytes. Okay, if I have say 32 exabytes, my 64 bits cannot generate the address for 32 exabytes. It can generate the address up to 16 exabytes. So memory size and the word size must be compatible with each other. Clock speed. The speed of a microprocessor is measured using a clock. What is the speed of a microprocessor? Clock speed is the speed of a microprocessor. That's all. But what is the unit of the clock? It can be at the most hours, and it from hours to minutes, from minutes lesser the minutes is the second, lesser the second, millisecond is there, lesser the millisecond, microsecond is there, picosecond is there, nanosecond is there, like that it goes on. Okay. So the clock speed indicates the speed at which the computer can execute instructions. In olden days, in first generation computer, the speed of a microprocessor was just hertz and kilohertz. With the advancement of technology and the microchip density, in the sense the number of transistors present in a microchip, that is called more number of transistors are present in the microchip, means higher chip density. It is now measured in gigahertz. Gigahertz means billions of pulses per second. So if the higher the clock speed, very powerful microprocessor. Higher the speed of a microprocessor, lesser the clock speed, it is less performance microprocessor, and its CPU processing capability takes a lot of time. It is slow. Now we move on to cores. What are cores? A core is a basic computation unit in the CPU. In first generation and second generation, third generation also we saw, fourth generation also we saw limited to single core, one core only. This is one CPU. See here, look here, single core CPU. The entire CPU is one processor, one core processor. How many processors are there? One processor, because there is a single core. In dual core CPU, CPU is one only. But how many cores are there? Two cores are there. How many processors are there then? Two processors are there. So each processor can execute millions and billions of instructions. If there are two cores, means there will be two processors. Physically, it is one single CPU. So each processor can execute billions of instructions in millimeters. In millimeters. Suppose if it is a quad means 4 cores will be there in a CPU, single CPU with 4 processors. Each processor can process in billions of instructions per milliseconds. 4 processors means each processor can process billions of instructions per millisecond. So more number of core means more processors in a single CPU, more processing capability will be present in that kind of microprocessor. So the CPU with 2, 4 and 8 cores is called dual core, quad core and octa core. The octa core in the sense there will be 8 cores in the single CPU. There will be 8 processors. Quad core means 4 processors. Dual core means 2 processors. And a single core means 1 processor. Let us study about the microcontrollers. What is a microcontroller? It is a small computing device which has a CPU, a fixed amount of RAM and ROM and other components in a single chip. What is the difference between a microprocessor and a microcontroller? In microprocessor, control unit and ALU will be present. In microcontroller, control unit, ALU unit, primary memory that includes random access memory, read-only memory and other components, everything will be present in a single chip. Let me repeat. In microprocessor, the CPU includes control unit and ALU unit. The microcontroller includes the CPU, RAM, ROM and other components in a single chip. That is the difference between a microcontroller with the microprocessor. The microcontrollers designed for specific tasks only. Specific tasks, not for multiple tasks, not for varieties of tasks, like we observe in the microprocessor. Microcontrollers has the limited processing tasks compared to microprocessors. Hence, their size and cost is reduced. It is embedded in another device or system to perform a specific functionality. To explain this, in my home, I have a washing machine. I have a air conditioner. A washing machine nowadays comes with a processing skills. That is microcontroller. A microcontroller will be present in the washing machine. It can take care of setting for different cloth washing, how much of water it has to take, in what time it has to clean the wash the cloth, how much of detergent it has to take, what are the different kind of activity, that is after washing, a single wash or double wash or even the wet cloth taking out from the washing machine, everything is programmed. That washing machine comes with a microcontroller. That microcontroller has a capability of controlling the activities of washing machine only. That microcontroller I cannot attach to the air condition system and expect all the work from that air conditioner. Similarly, my air conditioner will have a microcontroller that includes a CPU, a RAM, and a ROM. For what purpose RAM and ROM is used? I set the temperature. I use different modes of air conditions. So for that, there will be a RAM and ROM to store the data and the CPU to process. So the microcontroller designed for the air conditioner is attached to the air conditioner. Therefore, it is called embedded in another into the device. Embedded into the device. So a microcontroller designed for the AC will be embedded into the air conditioned device. A microcontroller designed for the washing machine will be present or embedded in the washing machine. Similarly, we have microcontrollers for the cars and many other devices. In robotics, we use microcontrollers. In biometric systems, we use microcontrollers. Okay, so the microcontrollers are the hardware that includes the CPU, RAM, ROM, and other components embedded into the single chip.